Good morning, students. Welcome back once again to our class at Easy Chemistry. Today we will be continuing with the topic of atomic theory or atomic structure. Okay, so now atomic structure. We understand that atom was the smallest known particle to a chemist at the start of the research work for chemistry. The time period I am talking about is way back in 1800s. Some people came up to 1913. However, without going back too much into history, I want to attract your attention to Niels Bohr's theory. Niels Bohr से पहले there were many chemists which provided different kinds of theories and different kinds of hypotheses based on the limited material they had for their research. Going back in time, it all started with Dalton, then came Rutherford, then came J.J. Thomson, ये तीन जो थे ये मेजर कंपटीशन थे because of which Niels Bohr in the year 1913 decided to provide some more insight into the structure of the atoms and the characteristics of atoms. However, as we all understand and as we all know, that at the time when something is being invented, we have many parallel researches going on in that particular world. So I am talking about the time of 1813s and 1819s. उस टाइम में हमारे पास एडवांस्ड रिसोर्सेज नहीं थे, बट कुछ ऐसे इंटेलिजेंट ब्रेन्स थे जिन्होंने ये चीज़ों को हमारे सामने रखा. So Rutherford model, it all started with Rutherford model had a major limitation that it could only account for electrons. J.J. Thomson model was a step further. He said nucleus, protons, electrons, which means J.J. Thomson was the first new chemist at that point in time जिन्होंने ये hypothesis दिया था हमें कि an atom is the smallest and the undivisible part of any matter in universe. However, that particular atom has a structure of an outer layer and an inner layer. Inner layer consists of neutrons plus protons. Outer layer consists of electrons. However, Thomson was unable to give us a concrete atomic theory because he was unable to establish the path of the electrons around the nucleus of the atom. So, the uncertainty principle, there was a chemist known as Heisenberg. Heisenberg said that due to the uncertainty of the position of the electrons, it becomes very tough to determine the shape of an atom. So, Heisenberg, and then comes in another chemist, his name was Rydberg. Rydberg was a physicist for a major portion of his life, but he also believed in the fact that an atom cannot be created nor destroyed, it can only be realigned. Because Dalton at the start of chemistry or the start of any science had said atoms are energy. So since Dalton was the one who said atoms refer to as energy, so Rydberg also understood and he had expressed that fact that even though the Heisenberg uncertainty principle does not allow us to provide a definite or a fixed shape of any atom, but there is a situation wherein an atom has the outer nucleus, has the outer path which is covered by electrons, and the central part which is covered by protons and neutrons. What Rydberg and Heisenberg, both of them agreed was this: protons and neutrons always remain in a given position at the center, which is nearly the center of the atom. So what Niels Bohr started off his theory with was atom, smallest part, however, subatomic particles equals to electrons plus nucleons plus proteons. Now, my dear friends, you would wonder, why have I written nucleons and proteons here? Nucleons and proteons were first called as nucleons and proteons because our scientists at that time had a fair notion that these are chargeless The notion of the understanding of the topic was so strong that protons and neutrons do not carry any charge, that if any substance was found positively charged, it was understood, or it was taken for granted by the scientists that these materials that are positively charged have less number of electrons, and the ones which are negatively charged have more number of electrons. So in a way we can say that the scientists or the chemists at that point in time only believed that electrons are the ones which were doing all the work of moving around, carrying charges, transmitting charges. So going by this fact, okay, wait, hold on. So before we are proceeding further with the Niels Bohr's theory, we shall revise one more concept, that was the Goldstein experiment. Okay. The other day when we met, we had slightly discussed about the Goldstein experiment. Don't take my drawing very seriously, but it's good to understand. Zinc sulfide, vacuum, ray of light, and gold foil. Okay students, the famous Goldstein experiment. There was a scientist who had at that point in time decided to decipher or to unravel the truth of how an atom is constructed. So what he did was, he took a tube, as you can see, a tube with a broader end on one side, two exits towards the end, and one is a normal exit. The two exits that were situated near the end was one which was to provide zinc sulfide in this hollow tube, and the other was to extract normal air. Now, towards the broader end, a gold foil was placed. A ray of light which was UV in nature was passed through this vacuum created tube with only zinc sulfide. Zinc sulfide, I am stressing on this chemical because this was my nuclear marker. The reason this was my nuclear marker is because of the fact that the scientists wanted to see when the ray of light hits on the gold foil, what kind of movement occurs. So, as per the experiment, 50% went straight, 35% deflected, 90%, 90 degrees, 12% deflected 180 degrees. This is 85, 97, 3% deflected 360 degrees. I want to remind my dear student friends that this percentage is what we have from various historical sources of the experiment, but they are not 100% being validated of late, because of late we have other instruments or other methods by which we can further bifurcate and further reach to an accurate percentage, but this is very, very close to the actual percentages. So when we run a ray of light through any kind of a medium, if 50% goes straight, what we mean by the fact is that that position is empty. As in, let's talk about it in a more relevant way. We want to hit a, while playing cricket, most of my friends would want to take up a straight throw at the wicket. Now if you hit the wicket straight, that's an undisputed run out. So there you are hitting the wicket, the 3 wickets are in front of your eyes and you are targeting an aim which is straight. Now comes the point of deflection by 90 degrees for 35%. Somewhere down the line, if you want to run the batsman out, you would want to give it to one of your colleague fielders in maybe a long on or a long off position, he would hit the wicket. So that's again a deflection of 90 degrees from long on or long off to the wicket. 12% deflected 180 degrees. 180 degrees would mean that straight line. So if you throw a ball from a deep mid wicket to your wicket keeper and he decides to throw it as a bowler, then that becomes 180 degrees deflection. 360 degrees deflection means you have decided to throw it to the bowler, but he decides to throw it to the wicket keeper because the batsman at that end is slow. So this kind of a deflection would mean 360 degrees. Coming back to our academic deflections, this is 90, this is 180, this is 360. So Goldstein experiment did help us to understand that the nucleus consisting of neutrons and protons is not scattered around the nucleus, is not scattered around the atoms, however it is located at a given position of the atom. And why do we feel, okay, so although we have been discussing for the last few minutes about the fixed position of the nucleus, so what we have been talking is, this is my nucleus, this is my electron orbit. Okay, so students, this Goldstein experiment did definitely give us a path or a base which may help us understand that in a circle, if we represent an atom in a circle, उसके सेंटर वाले पार्ट को हम बोलेंगे न्यूक्लियॉन्स और न्यूक्लियस, और जो बाहरी उसका जो एरिया है सर्कल का, that becomes my electron's orbit. Now coming to our Niels Bohr's theory. अब नील बोर थ्योरी पे अभी भी हम पूरा आने से पहले we will give you a further insight electrons or charge or energy. These have both wave properties and particulate matter properties. wave property plus particulate matter. So properties. So any kind of a electron will show both a wave property and a particulate matter property. What this means is I am explaining to you further. वेव की जब भी हम बात करते हैं हमारे पास ध्यान आती है मैग्नेटिक वेव, इलेक्ट्रॉनिक वेव. सो ये मेरा इलेक्ट्रॉनिक वेव. इलेक्ट्रॉनिक वेव की डेफिनेशन हो क्या होती है? मूवमेंट ऑफ अ चार्ज विच हैज बोथ अ क्रेस्ट एंड अ ट्रॉप. ये हो गया उसका क्रेस्ट, ये हो गया उसका ट्रॉप. अगर आपको इसमें ये समझने में दिक्कत हो रही है, then you can also call it as a plateau wave. प्लेटो वेव इसीलिए हम बोल रहे हैं क्योंकि दो पहाड़ों के बीच जो गैप होता है, that's called a plateau. Okay. Now coming back to crest and trough. अगर वेव प्रॉपर्टी है तो इसका एक वेवलेंथ होगा. वेवलेंथ is from here to here, which is point A to point B. अब अगर वेव है, वेवलेंथ होगा तो इसके साथ साथ एक फ्रीक्वेंसी भी होगी. फ्रीक्वेंसी इज डिसाइडेड एज frequency. When we talk about frequency, my student friends would normally be able to relate themselves with radio frequencies. Radio frequencies से जब हम बात कर रहे होते हैं तो what we are able to see nowadays is the radios, FM radios and the FM and AM radios. However, FM radios have a well-defined frequency, like for example in Delhi here they start off with 98.3 megahertz. So this 98.3 is a frequency. However, of late you must have heard of wireless devices working on radio frequencies. Those are our walkie-talkies being used by our different services, so we would not be covering that kind of a detail here. However, coming back to our normal wave property, so frequency of any wave particle relates to the number of waves passing through a point in 1 unit time. 1 unit time is normally described as 1 second. So the number of waves passing through a point in 1 unit time is called as a wave frequency. वेव फ्रीक्वेंसी का एक बहुत खूबसूरत एग्जांपल है हमारा हार्मोनिक मोशन का जो पेंडुलम क्लॉक होता है. आप आई एम श्योर आप सभी बच्चों ने अपने अपने शहरों में कहीं ना कहीं घंटा घर जरूर देखा होगा जिसमें घंटा लगा होगा. सो दैट इज कॉल्ड अ पेंडुलम. व्हाट हैपेंस इज द पेंडुलम ऑसिलेट्स बिटवीन टू गिवन पॉइंट्स. अब अगर आप बोर्ड के इस कोने पे ध्यान देंगे, then you would be able to see that this is more or less like that ghanta, and these are the two boundaries. So this pendulum of mine oscillates from point A, go back to point B, coming back here, and every time it passes the center point, the time increases by 1 second. So this oscillation between two given boundaries is termed as harmonic motion. And this harmonic motion is further represented by number of waves, 2 times the number of waves in unit time. So harmonic motion is described as twice the number of waves in unit time. So here we have been able to discuss the wave properties of electron or charges. However, we are yet to Okay. Now coming back to the particulate properties. अब पार्टिकुलेट प्रॉपर्टीज जैसे कि हमारा नाम सजेस्ट कर रहा है इसको is a wave property and particulate property. Both of them are different, but as the name suggests, particulate property उस मटेरियल की होती है जिसको हम पार्टिकल मान लेते हैं. Now consider atom smallest particle. However, for study we have broken down atoms into subatomic particles also. So even those subatomic particles have a certain area of space they occupy, have a certain small packet of energy that they have. So this subatomic particles, like subatomic particle, have small packet of energy called quantum. ओके बच्चों, हम ये क्लियरली जानते हैं कि atoms are the smallest particle. However, for study we have further divided those atoms into subatomic particles. Those subatomic particles are there for study purpose. However, even those subatomic particles have small packets of energy which is attached to them, and it is called as quantum. So if you have heard this term, going further you would also would have heard the term Planck's quantum theory. So now, while we are proceeding further with these topics, there are two things that we will be doing in our next class: Planck quantum theory, Niels Bohr's theory, atomic number, atomic mass, molarity, ओके. सो ये जो चार टॉपिक्स के नाम मैंने अभी भी बताए, दिस वी विल बी डूइंग इट इन आवर नेक्स्ट क्लास. हाउएवर, good to know information till then is, nowadays when I went through your syllabuses, I saw that there was a new branch, stoichiometry. तो ये देख के मेरे को थोड़ी चिंता हुई कि अब ये कौन सा नया ब्रांच आ गया केमिस्ट्री में. बट when I went deep into the topic, I found out that this was nothing but balancing of our equations. What this means is, the old concepts are now being repackaged and provided once again. So do not get nervous, stay happy, stay safe. Until then, keep chemistry in your mind and revise what we have done today. Thank you. Have a good day, all of you.